Right. So the squeeze theorem is just another method on top of the three methods of finding limit, okay? So the three methods I'm talking about is the substitution, right? Substitution here, simplify, that's number 2, conjugate, number 3, okay? If none of the three methods work, then you think about maybe this question has to use squeeze theorem, okay? So usually the question will, the function that you're trying to find limit will be something that's more complicated. For example, like question C on the next page, you have this one, right? X to the 4, right? Sine pi over X, or something that looks really uh, intimidating, right? And anybody remember this this function with a little hook at the bottom? What is it called? Jeffy, do you remember?
Sorry, which one?
The one with kind of like a
Oh,
box.
that one. The floor function.
Yeah, floor function. Very good. Okay, so something that's very different from other ones, then probably think about squeeze theorem. So let's go over what the squeeze theorem mean. Some textbook they just call it a sandwich theorem. Okay, so think of a sandwich, right? What do you have on a sandwich, Jesse?
I like chicken.
Okay, so you have chicken inside. So here is the chicken. Right, chicken. And then you what's above the chicken, Jesse?
Maybe honey mustard.
Okay.
No, I mean, just bread.
Okay. Okay. And then what's wrapping around it?
Onions.
Okay. Oh, wow, that's a stuff. Okay. Onion. Okay. And then of course above all the things inside we have the bread.
Bread.
Yeah, bread.
Cheese.
Oh, cheese. Okay. Cheese will be yellow. Okay, cheese. Okay. Or chicken. Okay. Now we have bread. So I'm going
Yep.
to use, oops, let's delete that. Okay, so bread and then another bread. Okay, so this part, the middle part that you have a lot of stuff. This is complicated, right? So this is the question part. So we call that the f of x, the thing in the middle. Okay, so because the thing inside in the middle is very complicated, so basically it's talking about whatever you see that's complicated here. This is the f of x, right? This is the f of x. So that's very difficult to find the answer. So instead, we find the limit of the top. So that's the h. So you can think of it as h for higher, right? The higher function. And then the g. G is, you can think of it on the ground, right? The lower function, ground. Okay? So instead of finding the answer to the f, we find the answer to h and g. If these two limits, the higher one and the ground one, they are the same, then the middle one will have the same answer as the other two. Okay, that's a general idea of what a sandwich theorem means. But you need to make sure the h and the g, they are like surrounding the f at the point that you want to find limit. Okay, you have to make sure that happens first. Okay, so for example, now if we look at the definition, right? So first of all, right, so first you need to make sure f is in between the g and h. Okay, otherwise this whole theorem won't work. Okay, you have to create a sandwich. So this is a sandwich already. You have to find a sandwich. All right, and then once you got the sandwich made up, right, then you find the limit of the ground, right? So g is at the bottom, and find the limit of the top, higher one, and they both equal to the same answer. Then, right, so step 2, you find the limit. Then you can say the limit of the middle one, you see the f, right? So you can say the limit of the middle one is also equal to L. So without touching the middle, right, you can still find the answer. That's the idea, okay? So the graph on the right side, so f of x is the curvy one, right? It looks very complicated. So suppose I want to find the limit approaching 1. Then I will find a simple function that's above it at 1. Okay, so for example, I will find a linear one, something like that, right, above it. Okay, and then I will find another function that's below it. So for example, I will find a parabola that's below it. So the green one will be the higher function, and then the red one will be the ground function. Okay, so if you find the answer for those two, and if they are the same, then you can say the middle one is the same answer. Okay, anyone has question? Anyone lost here? Just think of finding the chicken. Okay, making the sandwich. So let's start with a simple one first, okay? Well, it's a simple one in a calculus level anyway. So let's say here, limit of sine x, right? So this one is our f of x, okay? So of course, this one we don't need squeeze theorem because this one is a simple enough one, right? How do we find the limit for question A? Carrie? Without using squeeze theorem, how do we find the answer?
You can sub 0.
Yeah, we just sub 0 in, right? So what do you get when you sub 0 in?
Sine 0.
Yeah, and what is sine 0?
0.
Yeah, okay, so the too easy to be true, right? Too easy to believe. So the answer should be 0, okay? But here, let's pretend this is very difficult, right? I want to show the squeeze theorem steps, okay? So just remember the answer should be 0. So here, I want to, the sandwich, they already give it to you, okay? Usually, they don't give it to you, but just to help you, they give you 2 sandwich here. One here, another one here, right? One for sandwiching the sine, right? The other one is for sandwiching the cosine, okay? So let's show that the sandwich is true, okay? Let's draw the sine graph. You guys remember how to draw sine graph from grade 12? Still remember?
Yes.
Okay. How many points do we need for a complete sine graph? Leon.
Pardon me?
Yeah,
Can
yeah.
you repeat that?
How many points do we need to draw a complete sine graph? There are 5 important points. Do you remember, Leon?
No, I don't.
Okay. Can anybody tell me what are the 5 points?
Wait, 0, 0,
Yep. Okay. 0, 0.
and then pi over 4,
Pi over 2.
2, 2.
Mm-hmm.
1,
1. Yeah.
and then pi is 0.
Yeah.
Wait, and then do you want the negative side?
Sure. Yeah. We can go to the negative side.
So then negative pi over 2 is negative 1,
Mm-hmm.
and then negative pi is 0.
Okay, very good. Okay, or
Thank
you
you.
can go to the other side, right? This will be 3 pi over 2 will be here and go up. Okay, this is a good chance to review your trick, right? Negative pi, negative 2 pi. Remember seeing this? Your sine graphs. So make a curve. Right, opens up, opens down, opens up. Okay, take your time. And then I think I help you remember by using this chart, right? Sine, and then 0, 1, 0, negative 1, right? The arm exercise, remember? So you can use that as well. 0 is angle is 0, right? 1 is when 90 degrees, so pi over 2. And back to 0, and to negative 1, and to 0. So that's another way to remember it, okay? So now here, the green one is the f of x. Okay, so let's label that f of x. And then we want to find, so now you can look at the question, right? We want to approach 0. So I want to squeeze squeeze the function at 0. So the function that tell you that we can squeeze is absolute value of x. Okay, so absolute value of x is a V shape. So I'm gonna draw that. The V shapes. Okay. Later I'll show with decimal, okay, to show you better, right? But with better scale. So it will look like that. So this is the V shape, right? So this is absolute value of x, right? And then the other one, the lower one, I'm gonna use red. Right, this one. This is the red, negative of absolute value. So this is the lower one. This is the higher one. And the green one is the one you are interested in. Any question? Okay, so once you found the sandwich, right? Once you confirm, right? Because they already tell you it works. The picture is just showing that it does work, okay? So for example, here, let me share a window here, okay? Hold on. Give me 1 second. Okay. Let me show you decimals. Okay, so let's start with y equals sine x, right? So that's the graph. And then y equals to absolute value. So let's also do that here. Do we have absolute value? Here, functions. Do we have absolute value function for decimals?
It's underneath the X.
Okay, oh yeah, thank you. Okay, and then x. Okay. Does it show? Oh, here. Okay, and then y equals negative absolute value of x. Yeah, okay, so you can see that because my scale is not as good as this computer one, right? So at 0, the function is trapped in between, right? So the red one is the chicken, the blue and the green are the bread, right? Okay, you can all see the picture now, right? So let's put that away. So that's what it means. So once you confirm that, this is why you need to show, right? The calculation, the same thing, is not a lot. You just need to show the work the proper way, right? So we start by finding limit. Hold on. I need to go back to the sharing. Okay. Okay, so back here. So limit, we are going to take the limit of the higher one. Higher one is absolute value, right? And then we'll also find the limit of the lower one. Okay, so the limit of absolute value, if you remember from last class, okay, last class you had many questions about limit of absolute value, okay? I don't have the notes here because it's in the other file. Let me see if I can pull it up. Last week. Right, limit of absolute value over here. Right, the piecewise. Okay, I looked at your homework. Some of you still have trouble writing the piecewise function. Okay, so make sure I made some notes on your homework. Okay, so make sure you go over it. So anyway, so limit of absolute value in question C, we found it equal to 0, right? Even if there's a negative on the outside, it's still gonna be 0. So we can go back to that. Okay, so go back to here. So this equal to 0. That also equal to 0, right? From the previous work. Therefore, by squeeze theorem, okay, and then limit x approaching 0 of our function should equal to 0. So you see there's no work. Well, just minimum, right? You have to show these two. So this is your step 1 is to find a sandwich, right? Step 1 up here. Find a sandwich. If they don't give you, right? If they give you, then they have done step 1 for you. Step 2 is to find the limit of the top and bottom, okay? Step 3 is to just write a conclusion. That's it. Okay, so if you follow the top, right, it's the same thing. Step 1, right, get a sandwich up here. Step 2, find the limit of each one and make sure they equal, right? These two, they both equal to 0. Therefore, you say by squeeze theorem, the middle one has to equal to 0. Okay? So I would like you to try question B. Also see if you can get a graph, right? For the sandwich as well. If you don't know how to draw it, try with your decimals, right? And check it out. Okay, so once you finish the graph and the squeeze theorem, okay, the work, please raise your hand. Okay.
Wait, Jason.
Yep.
Do we write limit x approaching to 0, absolute value of x plus 1,
Yeah.
or plus include the plus 1?
Yeah. Because
Okay,
that's
thank you.
right.
Yeah.
So you find the limit of both bread, the upper bread and the lower bread.
Okay.
Is there anyone here still feel confused what to do? Let me know, okay? Then I can explain more. So make sure you got the picture, okay? Just to confirm the sandwich, right? The cosine x is in between the two graphs, right? Make sure the sandwich exists. The sandwich, it works. And also practice how to draw cosine graph, right? It's a good chance to review the graphs. Okay, Lex, can you draw the upper graph on the screen? And Emily, can you draw the lower graph on the screen as well?
I'm not sure if I can do it on my phone, cause
Oh, okay, you're using the phone. I see.
yeah, sorry.
Okay. How about you, Jeffy? Can you do the lower graph? Mm-hmm. Okay, okay, looks pretty good. Okay. Yeah. So at 0, right? It will be in between the yellow one and the light blue one, right? So it works. Okay, very good. Those two graphs are correct. Let's clear the drawing. Okay, so one, I will use my color here. Okay, so blue one will be above. Oops. Right, and then the red one will be below. Okay, so it doesn't cross. I don't think it crosses the green graph. Okay, and then therefore to show the work, Leon, how do you show the work?
Limit of x approaching 0,
Mm-hmm.
absolute x plus 1
Mm-hmm.
equals 1.
Yeah.
And then limit of x approaching 0,
Mm-hmm.
again,
Mm-hmm.
a negative absolute x
Mm-hmm.
plus 1
Yeah.
equal 1.
Yeah.
And then a limit of x approaching 0.
You have to write a sentence by
Oh, the by squeeze theorem.
mm-hmm. This is the most important. This is how you get a mark. Okay, mention the squeeze theorem.
Okay.
Yeah.
Limit of x approaching 0
Mm-hmm.
of cosine x
Mm-hmm.
equal 1.
Yeah. Okay, so they want to check if you know what theorem to use. Okay, to say. So don't skip the writing the by squeeze theorem. All right. And then, so that's it, right? So these two questions are very simple because they give you the sandwich. Okay, the hardest part is to find the right sandwich. So let's try another one that has the sandwich for you. Okay, so this one you don't need to draw the graph, right? So let you try this question 13. Okay, when you finish, please raise your hand. Let me lower your hands first. Jesse, you're already done. Okay.
Wait, I don't know if I did it right though, because um, like I don't know if we're supposed to plug in the numbers again, or
Yeah.
okay,
When you find the limit, you need to plug in the numbers.
okay. That was more a raise my hand to ask you a question.
Oh, I see.
Yeah.
How far are you? Are you on the next page already?
Oh no. I'm on this page.
Okay.
Yeah. I looked through a little bit of the book, but like most of it I haven't learned.
Mm-hmm. Yeah.
So
Going
I'm
into
just
more
going
detail.
along.
Yeah. If anyone is completely no idea, you can also let me know. Instead of just sitting there waiting, okay? Let me know what's troubling you, okay? Then I can help you move forward.
Jason,
Yeah, Jeffy.
can the f of x be d and e, or is there like a definitive answer for this one?
Unless the other, well, no. For this one, you will get the answer for sure.
Okay. Okay. I was just wondering.
Mhm. Because if you are able to squeeze it at a point, then they should meet at a point. Then limit should exist.
Okay.
So Leon, how do we start?
I'm not exactly sure if I did it right.
That's all right. You can tell me what you got.
I got for the final answer.
The step by step. What's your
Okay.
final answer first?
My final answer, I got 14.
14. Anyone else got different ones? Well, looks like everybody agrees. Okay. So Leon, what's your first step?
I wrote limit of x approaching 2,
Mm-hmm.
7x
Yeah.
equals 14.
Yeah. And then.
And then limit of x approaching 2,
Mm-hmm.
and then 3x squared plus 2
Mm-hmm.
equals 14 as well.
Okay.
And then by squeeze theorem,
Mm-hmm.
limit of x approaching 2,
Mm-hmm.
f of x
Mm-hmm.
equals 14.
Yeah. Easy, right? Okay. So this one is still easy. Just kind of summarize what we've been talking about. Get the sandwich, which is right here in the box, and then find each of their limits. Make sure they are the same. Then you can say by squeeze theorem, the answer is 14. Okay. So starting next page, I'm not giving you any sandwich now. Okay. So the harder part is how to get the sandwich. So let's look at the next question. Well, this one still kind of give you a sandwich. How about we skip B? Should we skip B? Do you know how to do B? Anyone want to talk about B? What
Yes, let's do B. Can we do all of them? They all look super hard.
Oh, okay.
Yeah,
All
I
right.
don't really
Sure.
know what's going on.
Okay. So if you hear the question is find the limit of this one, right? So this is your chicken, right? This is your chicken. Yummy chicken. Oh, okay. And then the bread, right? The bread that they kind of give you the sandwich up here, but however the chicken they give you is different. It's not really the question, right? They probably only give you a mustard. Okay, this is only a mustard. So how can I make it into a sandwich that we want? What do we do?
Please go on explaining, sir.
Huh?
Can
Really?
you? Yeah.
Okay, I'll try. Okay, because I don't want to give it away. I think.
Oh, you're giving us a hint. My
Yeah,
bad.
I'm giving you a hint. They give you a sandwich up here, right? F of x in between. But however, the question wants f of x over x squared. How can I make the sandwich? How can we create a sandwich?
Wait, can you make everything over x squared?
And how do we do that?
Is that legal? I don't know.
That's okay. That's legal. So how do we do that?
Just put everything over x squared. 3x squared minus 4x cubed over x squared is less than or equal to f of x over x squared.
Mhm.
Wait. I have a question though.
Yeah.
Because then, oh no, I see. We can substitute. Or no, we can factor out and then cancel.
Okay. So they give you a sandwich which is not exactly the same, right? But then we can make it the same by adding an x squared in the denominator. It's like adding ingredient. Make sense? You're trying to make a sandwich, but it doesn't have the taste that you want. So you want to add in the x squared, and then you will be happy. Okay. So now this matches the question, right? Then you got your perfect sandwich. Okay, so now your next step is to find the limit of the bread. So limit x approaching 0 of the upper bread, right? And then you also need to find the limit of the lower bread, right? And then see if they equal each other. And to find the limit, don't forget your 3 methods. Okay, Leon, what are the 3 methods?
Evaluate by multiplying conjugate.
Yeah, that's number 3.
Simplify.
Yeah, number 2.
And substitution.
Okay, so you should always start by substitution first. If it's indeterminate, then you go to try the other 2, okay? All right, so try these 2, get the answer. Once you get the answer for the 2 limits, the bread, please raise your hand.
Wait, so for B and C or for the?
For question B.
Oh, okay.
Yeah, we're still on question B. If anyone forgot how to do the limit, please let me know as well, okay? Don't forget to raise your hand.
Wait, Senor, I have a question.
Yes.
For if 3x squared minus 4x cubed, is that statement for B, C, D, and E, or is it just for B?
Only for B.
Oh, okay.
Starting question C, we need to get our own sandwich.
Oh, okay.
Okay, let's check some answers. Okay, Nicole, what's your upper bread limit?
I got 3.
Okay, and Emily, what's your lower bread?
3 as well.
Okay, so because they match, then you can say by squeeze theorem limit f over x squared is what? Lex?
It's equal to 3.
Equal to 3, yeah. Okay. Anyone has trouble getting 3? Leon, how are you doing?
I don't understand how you get 3.
How we get a 3? Okay, remember you told me the 3 methods, right?
Yeah.
Okay, what's the first method?
Substitution.
Okay, so if we sub in 0 into all the x, what do you get?
0 over 0.
Yes, okay, 0 over 0 is called,
Indeterminate.
Okay, so which means we need to start simplifying or multiply conjugate, right?
Hmm.
Okay, so how do you want me to simplify here? Can you tell me? How do we simplify here?
Factor out x squared, right?
Okay, so what's on the inside then?
3 plus 4x.
Very good. And then denominator?
Oh, and x squared.
Okay, and what do we do now?
And then cancel out x squared.
And the canceled out part, that's where the 0 over 0 comes from, right? Once you get rid of that, then we have no more trouble. Then what do we do next?
You can plug in 0.
Yeah, we'll try one more time, right? Substitute again. So what do you get?
3.
Yeah, okay, so that's how you get a 3. Got it? Okay. Yeah. Okay. So similar for the lower bread, you will also cancel out and you also get 3. Okay. So you get, and then you can say by squeeze theorem. All right. So you see everything's connected. What you learned before, right? You are putting into use here. So make sure you have to do the homework so you don't forget the things in the past. Okay. Okay. So let's look at question C. Question C has no sandwich at all. Okay, so here we are building our own sandwich. So how do we do that? Okay,
Wait, Jason,
yeah.
what do you like on a sandwich?
What do I like?
Yeah.
I like the avocado actually. Yeah.
Nice.
Yes.
Oh wait, you're vegetarian, right?
Yeah. And then I can have Beyond Meat. You know Beyond.
Oh, is it good?
Yeah, they are good. Those
I've
ones
never
you
tried it before.
buy and you get them from Costco. You can fry them at home. Very good.
Oh,
Yes. You should try it.
I will.
Okay, all right, so here we have sine pi x times x to the 4, right? So it looks so complicated. So when you build a sandwich, you have to start with something that you know, right? Something that's easier. So here we are going to start with sine x because we know how to squeeze sine x, right? Let's draw a graph as sine x, okay. So same thing, 5 points. Okay, so let's go here. I'll use red. 1, 2, 3, 4. Okay, so this is our sine x. And then I'm going to squeeze sine x. Of course, we can use what we learned last page, right? Sine x is in between the two absolute value. One is the open up, one is open down. But I don't like to use absolute value. It makes things more complicated later, okay? So another way to squeeze this is I'm going to choose just a simple straight line, okay? So I'm going to choose this one. What's the equation for that blue line, Jeffy?
Y equals 1.
Yes, very good. Okay, so this will be our upper bread, okay, for now. So sine x is less than or equal to 1, right? So it's either below or equal to it, right? It can touch it as well. And then the lower bread, I'm going to use the green color here, right? So that one will be the -1, right? Y equals to -1. So sine x is so far being sandwiched, okay, by 1 and -1. Now it,
Jason.
yes,
I have a question.
Yeah.
If if it was like sine, like if the period was different or there's like vertical displacement, does the top and bottom bread change too?
Yeah. The
Okay.
blue and the green will change because
Okay.
you need to make sure it's above it, right?
Wait, but
So
it always, like, the top and the bottom bread always depends on the highest point of the graph and the lowest point, right?
not really. It depends on, well, Yeah, you have to see because it has to be completely under or completely below above.
Oh, okay.
Okay. Yeah, so before, right? Before we also choose the absolute value, and then it's always above it, right? The blue is always above green.
Yeah.
So it has to be less than equal.
Oh, yeah, I see it now.
Okay, and then we are building the sandwich. The next part, we're going to adding some ingredient. So if I have sine pi x, right? I'm taking my next step. Instead of x, if I have pi x, is it gonna still be in between 1 and -1? What do you think? If I change the thing inside, do you think that the answer, right, whatever that comes out here, is it still gonna be between -1 and 1?
No.
It will change or no longer between 1 and -1?
Wait, pi over x, that,
You press the sign button.
sorry?
And then sign of that number, will that always be between 1 and -1?
Wait, I was thinking, like, because if you change something to the x, that changes the period, right? It doesn't change the vertical or,
Yeah, it doesn't affect the vertical.
yeah.
So,
Wait, would it still be in between 1 and -1 then?
right, so you agree with that, right? Okay, so we can also find out using the decimals. Okay, so let's also check that, right? With the technology, we can do that here. Let me change the sharing. Okay, so let's try decimal again. Because I'm also curious about what that graph look like, right? So we have y equals sine of pi. Do we have pi button? Yeah, okay, pi over x. Ah, see? Have you ever seen this graph before? Okay, so
Oh yeah, she said something, it's called like something oscillating or whatever, but I have no idea what she was saying.
yeah, so this is oscillate. Oscillate means like a wave goes up and down, right? But when you go to the middle part, right, it's so close together. And then if you draw y equal to 1, right, it's above it, right? And then y equals to -1, also below it. So even though the inside changes still in between the same bread, okay? So it's okay, right? And think about sine graph. It doesn't matter what inside is. Think of it like a box. Whatever that goes in here, right? If you hit the sign button on your calculator, whatever comes out is always 0 point something, right? Or 1 or -1. So it doesn't matter what's inside. So the question can change, right? Here they just give you power over x, so who cares? It's still between -1 and 1. So I just put that. So I got a better sandwich now, right? Closer to what I want. What else is missing in the sandwich? What else do we need?
Wait, what's the x to the 4?
X to the 4 is part of the chicken.
Oh, wait, but I thought our chicken is sine pi over x.
Yes, okay, so x to the 4 could be the cheese. Okay, so we still need a cheese, right?
Oh. Wait, do we have to do x to the 4s in between?
No, we don't need to just focus on x to the 4. We're trying to build the whole sandwich here.
Oh, so
Right.
we have to move on to x to the 4 sine pi over x?
We are slowly adding ingredients, trying to.
Oh, so the middle stuff is all of it, and then the 1 is the bread. Okay, that makes more sense.
Yeah. Okay, so initially we start with something involving sign, but it's not exactly what we want in the middle, right? So we are slowly changing the middle part become the question. Got it? Okay, so what else do we need to do now?
Wait, do we add the x to the 4 now?
And how do we do that?
Oh, can we do x to the 4 sine pi over x is in between absolute value of x to the 4 and negative absolute value of x to the 4?
Where did you get absolute value from?
The last page. I don't know if I'm doing it right though.
Last page is using absolute value x, right?
Yeah.
Here we don't have absolute value here. We are using 1 and -1.
Oh,
Continue building on what you have.
wait, so if you have to multiply everything by x to the 4, is it all of that in between negative x to the 4 and positive x to the 4?
Yeah, okay, so you just
Oh, okay.
add into it, okay? So the middle part, to make it match the question, you will multiply by x to the 4, right? If you are multiplying, then you do the same thing on the outside. 1 times x to the 4, -1 times x to the 4. So that's your sandwich. Got it? Right? So now it matches. So we are building step by step, trying to create a sandwich that matches the question. Okay, is everyone okay here? Anyone lost? Okay, so after here, we got the sandwich now, right? So what should we do now, Carrie?
You find the limit of the g of x and h of x.
Okay, so you start finding the limits of the bread. Okay, so I'll let you finish the last part. So the hardest part is to get the sandwich, right? Because the rest of the work is just finding limits. Okay, so when you finish, get the answer, raise your hand.
Wait, Jason, I still have a question.
Yeah, please ask.
If it's limit x approaching to 0, how do we do sine pi over x?
You can't. That's why we need a sandwich.
Oh, okay, yeah.
Remember, sandwich is for something that you cannot do by the 3 methods, right?
Yeah,
Something
okay.
difficult, right?
Thank you.
Yeah. So instead of focusing on the question, we focus on the bread. Raise your hand if you're done. Don't forget to raise your hand.
Sorry, I'm kind of stuck on what to do next.
Say that again.
I'm sort of stuck on what to do next.
Okay, like finding the limit of the bread. Is that where you? Okay.
Cause
Mm-hmm. Yeah, I can hear you. Are you saying something?
No.
Oh, okay. So can you tell me which one is the upper bread?
x to the power of 4.
Yeah, so I just write x to the 4.
Wait,
Yeah.
no, I was being stupid. Okay, never mind. I got it.
Okay.
Sorry.
Yeah, it's all right. No question is stupid, okay? So
I still don't understand this part.
okay, do you get the sandwich part? Like how we got the sandwich?
Yeah.
Okay, so once you have the sandwich, then you start finding the limit of the bread. Which ones are the bread? Can you tell me?
X to power 4 and negative x to power 4.
Yeah, so you find the limit of those two. So you have limit x to the 4 and limit x to the 4 and then with the negative. Got it so far?
Mm-hmm.
Right? It's the same step as previous, right? You find the limit of the plus and the minus, right? Last question. So how do you find limit now? Leon?
I'm assuming you just plug in 0.
And that method is called,
Substitution.
yes, you always try substitution first, unless
Yeah.
you get indeterminate, right? So what do you get?
Or you just get 0.
How about the lower bread?
You also just get 0.
Okay, then what do you do?
Well, it's not indeterminate, right?
Yeah, 0 is not indeterminate. 0 is a number.
Oh, so would the answer just be 0 then?
Yeah, but before you say that, you have to say,
By squeeze theorem.
yes, that's correct. Okay, you have to make sure the two limits are the same. Then you can say by squeeze theorem, limit of our chicken, limit of our chicken is what?
0.
0. Okay, so the last bit, right? This part is, it doesn't take much time. It's just regular finding limit. The longest part is how to get the sandwich, right? Okay, so keeping that in mind, I would like you to think about D. Okay, give you about 5 minutes. Try it on your own first. Okay, because this question also has a sign in there. So see if you can build up a sandwich that matches the question. Okay, so just let you try. Go as far as you can. Just give you a head start first. Okay, the initial sandwich is still this. Okay, and then you try to modify from there.
Wait, can we start with E or do we start with sine X?
Depending on how you progress, right? I started with this, right? Maybe you start with something else. It's okay. Yeah, as long as at the end it works, right? I can check your work later.
Okay.
And also when you build a sandwich, right, you want to make sure the bread is easier to find limit than the chicken, right? Chicken is supposed to be difficult, right? And then that's the whole point. You find the limit of the easy part to get the answer for the hard part. Anyone wants to check your steps?
Yes, please.
Okay, can you tell me, I'm gonna just draw a line here, okay? Can you tell me what you did?
Okay. I started with E because I wasn't sure how to modify the sign 1 over x.
Okay, so E, what's in
Is
the,
in between.
is there any X, E to the X or what?
Oh no, I just left that as E.
E is a number though.
Yeah, yeah. I just realized that. Okay, so would it be E to the x?
Okay, between,
-1 and 1.
is it? Is it E to X between -1 and 1?
I have no idea.
You have to know the graph of E to the X though.
Oh, my bad.
Right? If you're not sure about the graph, you can use decimals, right, to check it out.
Yeah.
The exponential graph,
Oh, wait. E to the x is exponential graph?
isn't it? It's like 5 to the X, right? Or
Yeah.
7 to the X. These are called exponential. Think about the log and exponent chapter.
Wait, so then it would be between 0 and, wouldn't it be infinity then?
So it cannot be bounded, right? So if you start with E to the X, you cannot make a same unless hold on, unless you have something like this, E to the X plus 1.
Oh, okay. Yeah, I
It will
see.
be always under. Make sense?
Yeah.
Yeah. However, the bread is not any easier than the chicken.
Yeah. Okay.
You want to get a bread that looks easier to do. Okay.
Okay.
Good try. Okay. You also learn from here too, right? Anyone else wants to check your work?
I'll check my work.
Yeah. Okay.
So I used sine x.
Yeah.
So from the previous question, for
Mhm.
sine x pi over x, you can do that here. So you can put in sine 1 over x, and it'll still be between -1 and 1.
Yeah. One.
And yeah, and then I sprinkled in the e.
And how do we do that?
So that'd be e to the power of -1.
E to the 1.
Yeah, and then e sine power to the power of sine 1 over x, and then e to the power of 1.
E to the power 1. So in between.
Yeah.
Okay. Yeah. That's your sandwich. It's good. Okay. That's what I would do. How's everybody doing? Any question on this sandwich? Anyone? Okay, so this is the sandwich that we want to use here. Okay, the idea we borrow from the previous question is whatever that goes inside the sign, it will always be between -1 and 1. Okay, it doesn't matter how crazy the inside is, right? Before we had pi over x. Here we had 1 over x. It doesn't matter. It's still gonna be between 1 and -1.
Okay, so as long as there's a sign, it has to be in between 1 and -1.
Because whatever you put into calculator, you hit the sign button, whatever
Oh yeah.
right,
Okay.
between 1. Okay, so I can put anything there, and then once you have that, right, then here we want to bring the e. It says we want to do e to the something, right? So e to a number. So if you know, let's say you can think of it like this way. If I have 2 less than 3 less than 4, if I make the base become e to the 2, e to the 3, e to the 4, is it still in between e to the 3? Is this
Yes.
true, right? Still works, right? It doesn't matter. So even if I adding an extra base, the inequality still holds. Okay? Make sense? Okay, so I forgot something, right? So we are not matching the sandwich yet. What else is needed? What other ingredient?
X squared.
Yeah, and how do we do that?
Multiply every single one by x squared.
That's correct. Okay, so we'll do x squared e to the -1 x squared. Oops. Right, and then x squared e. Okay, so that's the sandwich we are looking for, right? There is our chicken. Here are the bread. Okay, the breads are easy. Okay, once you get the final answer, please raise your hand. Anyone is lost, please let me know too, okay? I can explain the sandwich part again. Anyone is lost? Lex and Leon, any questions?
No.
Okay, are you done, Leon?
Would the final answers be 0 again?
Mm-hmm. Yeah.
But what is E though?
E is a number. Are you talking about the base here? What is,
Yeah.
E is just a number. E is
Oh,
2
okay.
point, I forgot, 2 point what? E is, let me see, 2.7182, kind of like pi, okay? It's a special number. When you finish, please raise your hand. Okay, so upper bread, right? And then lower bread. So Lex, what do you have for the two bread?
Uh, 0
And
and 0.
okay, so if they don't match, if the two answers don't match, that means the sandwich you chose, it doesn't work. Okay, it doesn't squeeze properly. So maybe you have to find a different sandwich. Okay. Right, last one. Let's see if we can finish this before time's up. This one is called a floor function. Okay, that Jeffy told us, right? Floor function. Do you remember the graph for the floor function, Jeffy?
Like what the graph looks like.
Yeah, this one, the y equal to floor of
Yeah,
x.
yeah. You want me to like annotate it?
Yes, please.
There we go. Oh, it's yellow. That's okay.
Okay.
Wait, Jason,
That's
Yes.
my-
what would this be in between then, though?
Yeah, that's what we're going to find out. We need to see the graph first, right?
Oh, okay.
Oh, that's a bad dot. Don't worry about that one.
Okay. Yep.
I think that's the basic idea.
Okay, very good. Can you draw another one on the left side?
Yes.
Okay.
That's supposed to be empty.
Okay.
My lines are not very good. There
Yeah.
we go.
Okay, good. All right, so based on the graph that Jeffy gave us here, can we find something to some graph to squeeze at? And that something has to be something easier, right? Something that's not floor anymore. Can we try? Can somebody try to draw a graph above and below, and that's gonna squeeze that? Simple ones, something that's like easy, like grade 10, grade 9 graphs. Something that's above, something that's below.
Wait, can I draw a line?
Yeah, you draw. You show me. Show us.
Wait, no, I don't want it. I don't want it to be on the screen. I don't know if it's right.
Well, it's okay. Come on. It's okay to make a mistake. We learn from it.
Okay.
Yeah, just show it. Show me.
How do I draw this?
Yeah.
Oh, something like that.
Okay, so slanted line, right?
Okay, it looks better.
Okay. Is it a curved line or straight line?
It's straight. It's very straight.
Okay, so this one is above or below?
Wait,
Is-
I got a question.
Yes.
Oh wait, no, it's above.
Okay, so the green line is above. Can someone else draw another line that's below? Someone else?
Wait, Jason,
Yes, Emily?
can you do the same thing,
Mhm.
but if you moved it down and then made it a dotted line?
Can you show me?
I'm on my phone. I can't really show you.
Yeah.
I'm sorry.
Okay. All right. Someone else, can you do what Emily said?
Wait, what were you saying?
That's all.
So if you took the line that you drew, moved it down to the empty circles, but made it a dotted line.
Oh, wait, that's actually genius.
Okay, so there we go. Okay, with everybody's effort, we got our sandwich right here. Okay. All right. Thanks everybody for the input. Okay, I'm gonna clear this and then draw it again. Okay. Okay, so the function that we want to do here is the lower floor function, right? So you can put it on your book. And then the sandwich, the above, we can do this one, right? So this one has an equation, right? This is the above function. And then the below, I'm going to use the green. You don't need to use the dotted line, right? Because it's a function as long as it's below, right, or equal, right? It could be equal, could be less than, right? So it doesn't have to be dotted line. So you can just use solid line. So this is going to squeeze the floor function. So we have floor of x in between the two graphs, okay? What is the equation for the higher graph?
Y equals to x.
Yes,
So
okay.
is it just
Okay,
x?
X, very good.
Okay.
And then how about the lower graph?
Is it x minus 1?
Correct, okay, it's a linear. Anyone has question about the two function, how we get that? Okay, so this one is our initial sandwich, just like we had initial sandwich of sine x, right, between 1 and -1. Here we have an initial sandwich of between x and x minus 1. And then now, just like sine x, whatever that goes inside, right, you have to expand your thinking now. Whatever that goes in here, it's gonna lower down, right? Lower down to the floor. So it will become this and here. Okay, it will be less than or equal to whatever that's inside or greater or equal to the inside minus 1, right? You can try it, okay? For example, let's say I input whatever number you can think of, okay? Give me an example. Carrie, give me any number, decimals.
0.3.
Okay, 0.3. So based on the theorem, I know it's gonna be less than or equal to 0.3 and greater than or equal to 0.3 minus 1. What's 0.3 minus 1?
Negative 0.7.
Okay. So what is the floor of 0.3? What does it, how do we do the floor function? It becomes,
It drags down, right? It drags down to 0.
yeah. So is 0 between 0.3 and negative 0.7? Is it? Huh? This is an easy question. Everybody should.
Yes, yes.
Okay. Yeah. Okay. So therefore, it doesn't matter what goes inside. It's always between, right? Whatever that's inside or inside minus 1. So now if I make the inside become 1 minus 4 over 1 over 4x squared, it will do the same thing. Do you get the idea? Okay, you can start building the sandwich. Okay, so if it's 1 over 4x squared floor, what would it be in between? Anyone?
Would it be in between 1 or sorry, what would it be? Oh yeah, would it still be 1 over 4x squared?
On which
But
side?
like without the floor.
On which side?
On the bigger side, on the right side. That's what it's called, right side.
1 over 4x squared, and then the left side?
Would it be 1 over 4 and then open bracket x minus 1 squared?
No.
Or is it 4x squared minus 1?
Yes.
Oh, okay.
Okay. Anyone has question? How we get that? Look at the red box, right? Whatever that goes in, it will bring it down, right? And then that will be less than or equal to the red box, but greater than or equal to the red box minus 1. It's a rule, right, from the graph.
Wait, so the minus 1, the minus, oh, I understand. Thank you.
Okay. Now what? Do we have our sandwich?
Wait, so when we include the multiply, wait, I don't understand, because if we multiply by x squared for everything, on the right side you can cancel out, but
right.
on the left side you can't really.
You try, you got to write it out. Okay, so you want to multiply now, right? Multiply x squared to make the sandwich. Multiply by x squared. I'm gonna do it slower. Okay, times x squared times x squared. Okay, so can we simplify the left side?
1 over 4 minus x squared.
1 over 4 minus x squared. Right side?
1 over 4. Regular
Okay.
1 over 4.
All right. So there you go. We have our sandwich. Right? This
And then we
is
take limit.
And then once you got a sandwich, you take the limit of the bread.
Okay.
That's the standard procedure, right? Are we good? So you take the limit
Yes.
of upper bread, limit of the lower bread. What do you have, everyone?
1/4.
1/4. How about other people, Jeffy?
Yeah, I got the same thing.
Okay. Anyone has questions so far? If you don't have question, please raise your hand. If you don't have question, then raise your hand. Jeffy, you have questions? Okay. All right. So once you got the limit, right, then you have to write by squeeze theorem and blah, blah, blah. Okay. So that's what squeeze theorem is about. Okay. It's a very good, thorough lesson here. So make sure if you don't understand anything, go back, okay, to the video. Later I'll upload it. And then I will post the homework again, okay, just like before. Okay. If we don't have any question, then we'll end the class here.
Okay. Thank you.
Okay, you're welcome. I'll see you on
Thank
Thursday.
you.
Okay, Thursday.
Yeah.
All right.
Mhm.
Okay.
Wait,
Bye.
Jason.
Yeah.
Bye bye.
Thursday's class, I'm only gonna be here until 6:30. So can I just watch the rest of the video?
Yeah. Yeah. Please do. Yeah.
Okay, so I'll be here for like the first
Good.
hour now.
Yeah. That's
Okay.
good. Okay.
Thank you.
You're welcome.
Thank you, Jason.
Bye bye.
Hey, Jason, would the homework be due next Monday or Thursday then?
Thursday.
Oh, okay.
Yeah, has to be done Thursday. Okay. Bye. If anyone has question, you can stay after.